All right. We're going to do the Chapter 5 study guide. Your test is tomorrow. All right, your test will be tomorrow. Whatever you do not finish in class today is homework, and I will be checking to make sure that you finished it tomorrow. Remember, we're talking about factors, multiples, prime numbers, composite numbers. Remember, a factor, the factors are the numbers that we multiply to get to a product. The multiples are when I am counting by that number. That's when I multiply that number. All right. Jackson was making a poster for his room. He arranged 50 trading cards in the shape of a rectangle on the poster. How many rows of cards were on his poster? Now, this is asking me which of these numbers is a factor of 50. Because if I have a rectangle, then I basically have an array. So I have a certain number of rows and a certain number of columns. So this question, it says how many rows of cards were on his poster. It's asking me which of these numbers is a factor of 50. So to find my answer, I am going to write the factors of 50. I'm going to do my factor rainbow. 1 and 50. Right? This is an even number, so I know that 2 is a factor. 2 times 25. I'm going to check 3. 5 plus 0 is 5. Well, 5 is not a multiple of 3, so 3 is not a factor of 50. 4 is not a factor of 50. 5 is a factor of 50 because 0, the last digit is 0, and that tells me that that's a 5. So 5 times 10. 3 is not a factor of 50, so 6 is not a factor of 50. 9 is not a factor of 50 because 5 plus 0 equals 5, and 5 is not a multiple of 9. So when I look at my list here, the only number over here that's on my list is 5. So my answer is 5. Remember, make your factors. Make your rainbow. All right? I'm going to do number 4 next. Elaine uses 19 connecting cubes to make a model of a house. The house model is in the shape of a rectangle and is 1 cube high. How many different ways could Elaine make the model of the house? This is asking how many factor pairs are there. So it's asking how many factor pairs are there. How many different ways can I make that rectangle? So in order to find that, I'm going to find the factors of 19. So I have 1 and I have 19. That's 1 factor of pair. All right. 2 is not a factor of 19 because 19 is an odd number. When I check for 3, 1 plus 9 is 10. 10 is not a multiple of 3, so 3 is not a factor of 19. Neither is 4, and neither is 5, because my last digit is not a 0 or a 5. 6 is not a factor of 19, because 2 and 3 are not. 7 is not. 8 is not. 9 is not. It looks like there is only one way, there's only one factor pair. So she can only make this rectangle one way. All right, let's go to my next set. Charles was skip counting at the math club meeting. He started to count by 8s. He said 8, 16, 24, 32, 40, and 48. What number will he say next? These are all multiples of 8. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6. So The number that he will say next is 8 times 7. And since I know my multiplication facts, I know that 8 times 7 is 56. All right, number 5. In a math game, Lee reads 4 statements about the number 39. She has to pick the true statement to win the game. Which statement should Lee choose? So here, if I'm looking at this is checking whether or not I know my divisibility rules. So the first statement is 39 is divisible by 2. In order to be divisible by 2, the number has to be even. It has to end in a 0, a 2, a 4, a 6, or an 8. 39 ends in a 9. It is not an even number. So 39 is not divisible by 2. That statement is not true. All right, the next statement is 39 is divisible by 3. Well, to check divisibility by 3, I add my digits. 3 plus 9. 3 plus 9 is 12. 12 is a multiple of 3, because if I count by 3s, 3, 6, 9, 12. So since 3 plus 9 is 12, then 39 is divisible by 3. So B is the true statement. 39 is not divisible by 5 because it does not end in a 0 or a 5. And 39 is not a prime number because it has more than 2 factors. All right. Number 3. Donna was helping her friend Dan with his homework. Dan asked Donna if the number 11 is a prime number or a composite number. How should Donna answer Dan's question? So, the only number that is neither prime or nor composite is 1. So 11C is not true. Because 11 is either prime or composite. It can't be both prime and composite, so that's not true either. So I can eliminate those answers right away. The next thing I'm going to do is I'm going to do my factors of 11. So I'm going to do my factor rainbow. 1 and 11. All right? Is 2 a factor of 11? Well, 11 is not even, so 2 is not a factor. Is 3 a factor? Well, I'll add. 1 plus 1 is 2. 2 is not a multiple of 3, so 3 is not a factor. Is 5 a factor of 11? Well, 11 does not end in 0 or 5, so 5 is not a factor. Is 6 a factor of 11? Well, 2 is not a factor and 3 is not a factor, so 6 is not a factor. Is 9 a factor of 11? Well, 1 plus 1 is 2, and 2 is not a multiple of 9. So 9 is not a factor. So 11 has 2 factors, 1 and 11. If a number has only 2 factors, it is a prime number. Let's go to the next page. All right, let's look at number 6. Jerry spent $42 to buy some shirts. Each of the shirts cost the same whole dollar amount. How many shirts could he have bought? All right, this question is asking me which of these numbers is a factor of 42. Because it's asking which of these numbers could I multiply another number with and get 42. So to find my answer, I'm going to do a factor rainbow for 42. So I'm going to start with 1 and 42. All right, 42 is an even number, so I know that 2 is a factor of 42. So if I divide 42 into 2 equal parts, I have 21. So 2 times 21 equals 42. 4 plus 2 is 6, and 6 is a multiple of 3. So 3 times a number will give me 42. So let's see, 3 times, well, 3 times 12 is 36. And then I have 6 more, so 3 times 2 equals 6. 36 plus 6 is 42. 2 plus 12 is 14. So 3 times 14 equals 42. So 3 times 14. All right, 4 is not a factor of 42. 5 is not a factor of 42 because 42 does not end in a 0 or a 5. 2 is a factor of 42, and 3 is a factor of 42. So if 2 and 3 are factors of 42, that means that 6 is a factor of 42. Well, 6 times 7 equals 42. And when my numbers meet, that means I have found all the factors. So now I have to look at my answer choices and see which of these answers gives me a factor of 42. And it is C. 6 is on my list of factors. He can buy 6 shirts if he pays $7 a shirt. All right. Brady's teacher wrote a row of numbers with a pattern. So here is my pattern: 21, 29, 26, 34, 38, 39, 36. Now I have to find the rule for the pattern. Well, between number 1 and 2, I added 8, and then I subtracted 3. The difference between 26 and 34 is 8, so I added 8. 34 minus 3 is 31, so I subtracted 3. 31 plus 8 equals 39. Are we finding the pattern? 39 minus 3 equals 36. So what is my rule for this pattern? Well, do I subtract 8 and add 3? No. I add 8 and subtract 3. So I don't add 5. Here we go. Add 8, subtract 3. So I'm going to circle this one. The reason C is the answer and not D is because I started with 21. If I had started with a different number, D is a very similar pattern, but I started with 21, so C is my answer. All right, let's look at 7. Mr. Jacques wrote a bonus problem on the board. If Gina correctly answers, she gets extra time to read. The problem is to write a statement that correctly relates the numbers 9 and 18. Which should Gina write? 18 is a common multiple of 9 and 18. 27 is a common multiple of 9 and 18. 9 is a multiple of 18, or 18 is a factor of 9. All right, so I'm going to get rid of these last two statements first. 9 cannot be a multiple of 18 because multiples cannot be smaller than the number. So that is not true. 18 can't be a factor of 9 because a factor can't be larger than the number. So that is not true. So let's write my multiples of 9 and 18. So here's my 9 and here's my 18. All right, so my multiples of 9 are 9, 18, 27, and 36. I'm going to stop there. Let's do my multiples of 18. 18, 36, let's see, 18 times 3 is 54, and I can stop there. Because is 27 a common multiple of 9 and 18? Is it on both lists? It is not. But 18 is a common multiple of 9 and 18 because it is on both lists. So A is true. All right, number 9. James has a card collection with 64 basketball cards, 32 football cards, and 24 baseball cards. He wants to arrange the cards in equal piles with only one type of card in each pile. How many can he put in each pile? This question is asking about common factors, because it's saying how many groups, how many cards can I put in each group and make sure every group has the same number of cards. So this is looking for common factors. And it's looking for common factors for the numbers 24, 32, and 64. So I'm going to make my factor rainbows for these numbers. All right? I'm going to start with 1 and 24. 24 is an even number, so I know that 2 is a factor of 24. 2 times 12 is 24. 2 plus 4 is 6. 6 is a multiple of 3, so I know that 3 is a factor of 24. 3 times 8 is 24. 4 times 6 is 24, and 5 is not a factor of 24 because 4 does not end in a 0 or a 5. So there are my factors of 24. Next, I'll find my factors of 32. I start with 1 and 32. 32 is an even number, so I know that 2 is a factor of 32. 2 times 16 is 32. 3 plus 2 is 5. 5 is not a multiple of 3. So 3 is not a factor of 32. I know that 4, because I know my times tables, 4 times 8 is 32. 32 does not end in a 0 or a 5. So 5 is not a factor of 32. 3 is not a factor of 32. So 6 cannot be a factor of 32. And neither is 7. So I've come to my other factors, so my factors have met. I've found all the factors of 32. 64. I'll start with 1 and 64. 64 is an even number, so that I know 2 is a factor of 64, and it's 2 times 32. 6 plus 4 is 10. 10 is not a multiple of 3, so 3 is not a factor of 64. 4 times 16 is 64. So 4 is a factor of 64. 64 does not end in a 5 or a 0. So 5 is not a factor of 64. 3 is not a factor of 64. So 6 is not a factor of 64. 7 is not a factor of 64, but 8 times 8 is 64. Now, I'm looking for, remember, the common factors. That's the numbers that are on all 3 lists. 1 is on all 3 lists. 2 is on all 3 lists. 3 is not on all 3 lists. So that eliminates answer choice D. 4 is on all 3 lists. Oh, I've eliminated A because there are a lot more choices. All right. 6 is not on all 3 lists, but 8 is on all 3 lists. 12 is not on all three lists, and 24 is not on all three lists. So my common factors are 1, 2, 4, and 8. My answer is B. All right, let's go to number 10. Serena has several packages of raisins. Each package contains 3 boxes of raisins. Which could be the number of boxes of raisins Serena has? So this question is asking about multiples of 3. Okay, because if she has a package, each package has 3 boxes. So I'm looking for which of these numbers is a multiple of 3. So let's count by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and 33. Which of these numbers is on my list of multiples of 3? There it is. Number 18. So A, she could have 18 boxes. All right, Jill wrote the number 40. If her rule is add 7, what is the 4th number in Jill's pattern? So she wrote 40, and her rule is add 7. So 40 plus 7 is 47. Plus 7 is 54. Plus 7 is 61. So I'm looking for the 4th number. 1, 2, 3, 4. The 4th number is 61. 68 is the 5th number in the pattern. All right. Number 11. Lee will use 16 connecting cubes to make a model of a playground. The model will be in the shape of a rectangle and will have a height of 1 cube. In how many different ways can Lee make the model of the playground? Do you remember what this is asking? This is asking how many factor pairs. So let me count. I'm going to make a rainbow. 1 and 16. There's 1 factor pair. 2 times 8. There's 2 factor pairs. 3 times 3. No. Or 3 times a number? No. And then 4 times 4. Now, when I write 4 here, it doesn't have a pair, but 4 times 4 is a pair. So how many pairs are there? There's 1, 2, 3 factor pairs. So she can make her model in 3 different ways. All right, Eric had 13 tiles to arrange in a rectangular design for the top of a box. He drew a model of the rectangle he could make with the 13 tiles. What can Eric conclude about the number 13 from his model? So if I take these 13 tiles, the only way I can arrange them in a rectangle is to have 1 and 13. That means there's only 2 factors for 13. If a number only has 2 factors, it is a prime number. All right, let's go to the next page. Ms. Keller made 4 dozen cookies. She needs to put them into equal groups so that the number of groups is greater than 5 and less than 13. What are all the possible equal-sized groups she can make with the cookies? So this is asking me, first of all, I have to know that 4 dozen cookies is 48 cookies. And it's asking me for all of the factors of 48 that are greater than 5 and less than 14. So I'm going to write my factors of 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Now, she can have 6 groups, 8 groups, or 12 groups, because those are the ones that are greater than 5 and less than 13. Okay. Violet and Victor were playing a game. Violet was counting by 8s. Victor was counting by 5s. They paced the counting so they would say the first common number together. What is the first number that they said together? So this is looking for the common multiple. The first common multiple. We call that the least common multiple. So Violet is counting by 8s and Victor is counting by 5s. So let's start with 8. 8, 16. I'm going to use my divisibility rules, and I'm going to stop when I get to a number that ends in a 5 or a 0. So I have 8, 16, 24, 32, and 40. My guess is 40 is the least common multiple. Let's count by 5s. 5, 10, 15, 20, 25, 30, 35, and 40. The first number that they will count together is 40. That is the lowest common multiple of 8 and 5. All right, we have done 1 through 16 together. I want you to finish up, and I want you to do numbers 15 through 25. If you're confused about what it's asking for, go back and look at some of the other questions to see if you can figure out what it's asking. We will go over these tomorrow if you have a question about how to answer them.